Hello, so this is part two to our Tetris using Java programming language. And so I'm going to take you through. Let me first run the program, show you the new features, and then we'll go over the code that we use to get those features to work. So we have our pieces going down the board just like before, but now we can go left and we can go right as well, and it protects, doesn't allow you to go off the board. And you can rotate, as you saw there. So these will allow you to rotate. That one, I'm still thinking of fixing that. I think it rotates a little too far. But I like that. I think that rotates pretty well. Obviously, this one does not rotate. Any of the ones that you think should rotate differently, I mean, I really need to probably just play the game and kind of see how they get them to rotate. But it's an easy fix, and I'll kind of show you how to do that. So I'm pretty happy with that, though. And so let's take a look at the code that got this to work. So I'm going to stop that there. All right, so I updated the code. This is my part two, and so I will share this code in the description. So take a look there. So I kind of noted with some comments where the new things were, and here's the first thing that's new is we're going to use, well, this actually was already in the first video, this variable, but we use it, we put it to use, and this though is brand new. A integer variable called config, which is kind of used by the rotation function. It's number one. We have it set to one to start out with. That is the original configuration, and then we increment that, and so there's four possible configurations, right? As you rotate around, and so that's what this denotes, and I'll show you how we use that. All right. All right. So here's the next thing that's new. We had these key listeners and a key pressed, but we weren't really, we had nothing in it, and now we are looking for specific keys, and this denotes the left, this denotes the right arrow, and this is the up arrow. And accordingly, this calls a function called move left, move right, and rotate for the up arrow. And so we'll take a look at what they do. Again, I just want to show, so this function we already had, create new piece, but I reset our configuration back to the original configuration, which, as I said earlier, is 1. And so every time a new piece is generated, we put that back to 1. Let me stop here for a second. So we have our move down. That is untouched, but we have our move left and our move right. That simply see if they can move. And I created a new function here called can move side, which is slightly different than the can move. And I actually altered the can move function so that it really just deals with moving down the board and looking to see if it has touched another piece. Where the can move side is more concerned about moving left to right. And that's this is a move left, so we actually subtract from our current column, because remember the far left on our board is 0. So this row here is this column here is column 0, and so if I want to move left, I'm subtracting. And likewise, the move right has a current increment. We add to the column, and so that does that. And so let's take I'm going to stop that. So let's take a look at our can move. This is changed a little bit. Like I said, it just deals with going off the board. So we look at the height of the board, and also looking to see if we touch another piece, which that is not really in play yet, because we don't have pieces remaining on the board yet. That'll be the next video. So yeah, so that's it. And if we look at when we call this, we're adding one to the row to see to basically see, hey, can we still go, or are we going off the board? That's basically what this is doing. And likewise for the move left, we subtract from the column, the current column, and we add in the move right. And so if we look at the can move side, that this right here, it comes into account in this variable, in this method. The col variable is added to the current piece, and we see if we go off the board to with the width, or if we become less than 0. Pretty simple, but and honestly, I could have probably left these in the same method, just having a 1 can move, but I like the idea of breaking them out just for visualization, and the logic just kind of made more sense. That this one deals with the moving down and the touching the pieces, and this is the side by side. All right, so that's for that. And then here's I think right up until this point, everything is pretty straightforward. This one gets a little tedious, the rotate function. It's not that complicated, but it definitely is a little tedious. So we increment our configuration, as I said. The 1 is our original configuration. There's only 4 options, so once we go over 4, we have to reset it back to 1. So that's what's happening there. Remember, the pnum represents which piece. It represents one of these rows in our of our Tetris pieces, right? And so that gets a random number every time we create a new piece, right? So I just want to show that. So I'm coming back down here. So 0 represents the square. We don't need to do anything. The square doesn't rotate. If we rotated it, you wouldn't be able to tell the difference. So we just leave that alone. I could really just remove this, but I just wanted to keep it in there so you could see. And then 1 is represented by the line, the long line. And that row only, honestly, I could have just did a modulus 2 here, because there's only 2 options here. It's either a straight line horizontally or vertically. But I just gave it 4 different configurations. And all this is just resetting the coordinates, which I honestly used this, which I showed in the last video, just to make sure I got it right visually. I kept tweaking it. Like, so this is the Z looking piece in Tetris, and so if you look here, 1 0 is represented here, 0 1 is this one, 1 1 is this one here, and then 0 2 is this one here. And so that's what I used. I made sure this matched up to this configuration, and then I just kind of copied and pasted up here, and I did that for all of these. That was the tedious part. And just so you see, like, so the rotate would rotate clockwise, and so this would become this here. So that's the next iteration when config equals 2, right? And so on, and then like back to this configuration for config equals 3, and just keeps on going. So, and that's each of the shapes in here: the T shape, the Z shape, and the L. All spent a little time with this diagram, just making sure I had the coordinates right for each rotation. There's probably, let me know if you come up with some algorithm for doing this a little more elegantly, but this seemed to work. I couldn't come up with an algorithm for like subtracting or adding to these coordinates that worked for the pieces. Future video maybe. Anyway, I didn't touch anything past that. So that's it. That's all the code. Like I said, I'm sharing this code. Let me know what you think about this approach. I would like to probably come up with a better way of doing this, but for right now, that's what I'm doing. We just set the current piece to a new configuration every time we rotate. All right, so yeah, as I said, let me know. Please leave some comments, and look out for part 3 coming soon, where we will deal with the pieces staying on the board and clearing when you have a full row of pieces. All right, thank you. Have a good one.